Okay, in this video, I'm going to talk about tolerance. So, tolerancing is very important when you're designing parts, whether it's fitting or how certain things should be aligned. Those are all very important. So, there's typically like different types of fits that we will be working with. We have what's called like slip fit and then press fit. Okay. So these are the two main common types of fit that you'll be working with, and then there's also like interference fit and other specific um, terms out there. But we're just going to consider these two as the main ones. So typically, when you're dealing with tolerance, so tolerance is the idea of tolerance is if you have some dimension. So let's say 5, and then you have 0.00. So usually you want to have a number, and then based on the number, you'll have certain number of decimal places. And usually the number of decimal places you show is how tight your tolerance will end up being. But it's usually shown using like plus or minus and then the tolerance value. So let's say, for example, you have 5.001. So what does that mean? It means you have a number 5, and then the minimum is going to be 4.999, which is 5 minus 0.001, and then the upper limit is going to be 5.001. So this sort of tolerancing is called a symmetric tolerance. Symmetric because it's the same for the plus and minus. Um, here's actually I should probably write the max on the top and the min on the bottom. So let me just change that real quick. Gonna move the max on top, and then the min is gonna go on the bottom. So that's max and then min. And then you also have what's called the bilateral. So you might have 5.000, and then you have what's called a plus. You'll have 0.001, and then you might have a minus 0. So in that case, this sort of format is called the bilateral. Bilateral because the plus and minus values are different. So here you'll have a max of 5.001 and then a minimum of 5.000. Okay, so this is your max and this is your min. Okay, so these are the two main common types of ways you could write out a tolerance. So if you're dealing with slip fit or press fit, the main difference between these two fits is that slip fit is something that can slide in and out pretty easily, but still have a very good fit. So that's a slip fit. And then typically, let's say you have a plate here. Okay, so this is my plate. And let's say you have a dowel that's trying to fit inside a hole here, and you want it to be a very precise fit, but you also want it to be something you can easy to take out. Okay, so slip fit is easy to remove typically. So you want to have something that's a slip fit. Typically, how you would tolerance this is, let's say maybe your dowel is 5.000, and then usually they might have it slightly undersized, so they might have something like plus 0 minus like 0.001 or something like that. And then the way you would tolerance your hole here, um, you might have 5.0001, and then you could do like a plus 0.001 and a minus 0. Okay, so if we take a look at this, what it means is, let's use a different color. How about a dark green? So here we have 5.000 as the upper limit, and then the minimum is gonna be 4.999, right? And then here we have an upper limit of 5.002 and a lower limit of 5.001. So you could see the worst case if, for example, we hit the maximum here, and then let's say we hit a lower limit here, then we see that our worst case fit is gonna be 5.000 minus 5.001, which is gonna be 0.001. So this is gonna be our smallest gap that we could possibly get if we were to use this sort of tolerancing for a slip fit. And then the biggest gap we could get is, you could see here we have, um, let me use a different color. Let me use a red. Okay. So let's say we have 4.99 with a 5.002. Then we're going to get 5.002 minus 4.999. And then you have 0.003. So you can see in either cases, we're always going to have a net positive gap, which means that between the shaft and the hole, there's going to be some gap in between, where this is the biggest gap, and then the other one in the green is our smallest gap. Okay, so there's going to be different standards out there. You're going to see with like the numbers H7, or they'll have like different ways of like tolerancing the shaft and the hole. Those get really detailed into tolerancing. Here, I'm just gonna go over some like basic rules. You can look into the details of that later on. But here you can see, this is typically how you would go about designing. Is you always want to consider the best case and the worst case, and then see, if your spacing is good enough, right? So we could take the same idea and apply it to a press fit. So let's go ahead and just take a look at that. If we look at press fit, so let's say we have that same plate example, right? So here we have our plate. So this is our plate, and then maybe now we want to press fit a dowel inside. So again, maybe this dowel is gonna be like 5, and then maybe plus 0, and then minus 0.001. Maybe you could also find a dowel that's like slightly oversized. I think they might sell that too, but let's just use the same dowel for the sake of this example, to be similar with the dowel, but we'll dimension the hole differently. So here, what you want to do instead is, notice that the number here, this here is what we call like nominal diameter. So nominal diameter is like the dimension before you add the tolerancing to it. Okay, so whenever you see like, whenever you see the plus and minus part, this is your tolerance. I'm gonna put TOL for short, and then the number in front is gonna be your nominal value. Okay, so here with the press fit example, okay, so this is for press fit. So with the press fit example, right, we want to have our nominal diameter already a little bit on the small side, or like just right. So we can make our hole like 5.00 to start off with. And then we already know here that you're gonna have an upper limit of 5 and a lower limit of 4.999, right? So we know that we wanted to somehow interfere. So here you could do something like 5, like plus 0, and then maybe minus 0.001. Okay. So actually, you can see here that there's a chance that it's going to be, so this is the hole. You can have the hole that's like 5 and the shaft 4.99. So here you have like a gap, net positive gap of like 0.01. So in this case, you see that it might actually be better to have a shaft that's like slightly oversized. So in that case, based on this analysis, we're gonna change this to a shaft that's a little bit oversized. And there's actually hacks too if you actually get a dowel that's a little bit um, too not the tolerance you want, like you want it to be a little bit fatter. You could take a hammer and just hit it on the head, and then it'll kind of mushroom a little bit. So those are some hacks you could do. There's also ways you could hack by hammering your plate to change the tolerancing it, but that's another story. But anyway, so like for here, you could do something like as we see now, you can see the upper limit is gonna be 5.001, right? And the lower limit is gonna be 5. And then here we have a upper limit of 5 and a lower limit of 4.999. Okay. So now if we take a look at it, we can see our in red, we're gonna see 4.999 minus 5. So that's gonna be, let's see, we want 4.999 minus maybe the biggest one, so 5.001. It's gonna give us a minus 0.002. So it's gonna be an interference of 0.002. And then the other case in green, we might have like a 5 minus a 5, which is 0. Okay, so 0.002 might be pretty tight. So you might tweak around with the tolerancing. This is just an example, but you can see this is our this one is our min case, and then in our red here, that's our max case. So negative because it's interfering in the other direction. So we know that there's always going to be some overlap. So if I were to draw out my shaft here, so let's say the red is my shaft, and then you might have, let's just make blue my dowel, or my hole actually. So this might be my hole. So what this negative 0.002 means is that there's a gap, total gap of 0.002 on either side. So the shaft is slightly bigger than the hole by that much. Okay, so that's the idea of press fit. So we talked about slip fit here, and then we talked about press fit. Those are the two main type of fits. And then those both use bilateral tolerancing. Typically for symmetric tolerancing, you'll see that a little bit more if you're trying to deal with like positional tolerancing. So if you're trying to like design a part here, right? And then you have some holes that you're trying to design. So based on your hole location, you might tolerance your hole. Maybe this is 3. The location, you might do like plus or minus 0.001. Okay. So that's how you would go ahead and tolerance your parts. So throughout the videos, I will be kind of using some of these concepts as I'm fitting certain parts together. But from here, you can at least see how some of the things are considered when you design again. So again, this one is for usually position accuracy. Okay, so actually let's take a look at an example using what we just said. So let's say we're shopping for dowel pins here. Um, let's just say we were dealing with metric, and then yeah, let's say we're getting a 5 millimeter. Let's just say 5.5 for both. So if we look at product details, okay, so you can see here that this dowel pin here is actually oversized, right? It has an upper limit of plus 0.012 and then plus 0.004. So one thing to note, here I was actually talking about it in terms of inches. So I should have specified that. So those are in inches. So you can see here, um, this is in millimeters, right? So you have in millimeters, if we say like point 0.012, for example, 0.012 millimeters to inches, you can see that's 0.004. So that's like half a thou up, and then the lower limit is 0.004, for example. So 0.004 or 0.020, it's not 3. So here you can see the lower limit is gonna be um, like 1/10 of a thou. Okay, so make sure here I use 5, like as in 5 inches, but here I'm using millimeters for the sake of let's just actually look at a inch one. It might be a little bit easier, so that way we won't get confused with units. But let's say we're looking at, let's say like a, for simplicity, a 1 inch dowel. Okay, so if we're looking at a 1 inch dowel, you can see this one here has a plus 0.0003 inches, and the lower limit is plus 0.0001. Okay, so that's the sort of tolerancing that you're dealing with. Let's just choose a longer dowel. Okay, so you can see this is about the same tolerance. So we're gonna go ahead and download this, and we're gonna put it in our tolerancing. Okay, so here this is not as oversized as we talked about in our video, but the same concept will apply. So if we go ahead and make a new part, so okay, I'm gonna, oh, this is a drawing. Let me see. Cancel this. File new part. So I make a new part, and then I'm gonna sketch on the top plane. And I'm not gonna bother dimensioning this right now because it's just a quick example. But if I come here and go to Hole Wizard, you can see that I could go ahead and make a hole here. So there's different types. I could do like a dowel hole, and I want it to be inches. And you can scroll down to find your size. I actually got a very big dowel. It's like the biggest dowel actually. But you could go ahead and place the position here. I'm going to put in the center. And then you can see that's your dowel size. So here you have a sketch of it. And then if you were to make the drawing, you could change the size. But if you're press fitting and you're following the same rule that we had here, so if we press fit, we usually make the nominal hole size the same size, then you're pretty much all set. So in this case, my plate's a little bit thin. They actually usually recommend you to press certain. If you want it to be stable, you might want to have like 1 to 1.5 times the diameter of your shaft. There's different rules based on where you're from, but I'm just gonna make this like a 1/2 inch. Call this plate tolerance. Okay, I'm gonna call this, yeah, it's gonna be my plate. So if I go make a drawing from the part, I'll make it a B size, sure. So if I put this top part here, right? Okay, so if I go to Hole Wizard, um, where's Hole Wizard? Yeah, Hole Callout, actually. So you can see here is the one. Notice that there's only 2 decimal places. So where we like to work with 3 decimal places, so you could change that here. And then here you could have the bilateral. And then because it's a press fit, you want the hole to be slightly oversized. So we're gonna say 0.001 and then -0. Okay, so this will be how you would tolerance it to make wait, actually it should be under. Yeah, I'm gonna make this 0, and then make this, yeah, I want it to be smaller. So plus 0 minus 1, right? So if we look at what we drew here, plus 0 minus 1. So this will ensure that there's going to be some sort of interference when it's being fitted. And then the next part is if you have the tolerance in terms of the location, I could do some ordinate dimension here with our 0. And then here, if the location is important, I could do this to be like a symmetric tolerance of like plus or minus 1. And you can also add in the other dimension in the other way. So I could do 0 here. And then here I could change this to be 3, symmetric, and then 1. Okay? So that's how you make a part and specify the drawings to show the tolerance for both the hole and the location. Okay, so that's pretty much how you do tolerancing. We call this plate drawing, save it. So hopefully you found this video helpful. And if you did, give a like and subscribe, and I'll see you in the next one.